Hello everyone, welcome to 369 Chemistry, and in this video we are going to talk about the most repeated MCQ questions which comes in your NEET examinations on the chapter of your coordination compound. So this is the sum total of all the questions we are going to do in this chapter. Okay, this is not a video where you will understand the topic. We are just going to solve as many as questions possible. Okay, so if you want to understand the topic, you can go through my other videos. Okay, so let us go to the question number 1. See here, CONH3 whole 6 3 plus is a homoelectric complex, whereas CONH3 whole 4 Cl2 plus whole plus is your heterolytic complex. So there is two statements given below out here. Okay, and the complex CONH3 whole 3 plus has only one kind of ligand, but CONH3 whole 4 Cl2 has more than two kinds of ligands. So here two statements are given to you and you have to choose the correct answer, which one is correct. So first you have to know what is your homoleptic species complex and what is your heteroleptic complex. Homoleptic complex means which contains only one type of ligand, and your heterolytic complex means which contains more than one type of your ligand. So first see here, the first statement is also correct. The second statement, which also says that it has one kind of ligand, so it is also true. Okay, so your answer will be both 1 and 2. Okay, we will go for question number 2. Now homoleptic complex, from the following you have to find out which one is a homoleptic complex. See here, potassium trioxylato aluminium 3. Okay, the second one is your diamine chlorido nitrito and platinum 2. So homoleptic means only one type of ligand. See here, there are more than one type of ligand. Chlorido is there, chlorine is there, nitrito is there. Okay, so this is not going to be the answer. Okay, the second one, see here, it is pentamine carbonito cobalt 2 cobalt 3 chloride. So amine is there, carbonito, carbon monoxide is also there. So this is not going to be homoleptic. Then another one is your triamine triaquachromium 3 chloride. See here, aqua, that means your water molecule is there, amine is there. Okay, so your this is also not your homoleptic species, only the first one, which is your potassium trioxalate aluminate, that is your you can say that is your homoleptic species. See here, potassium, it is a cation, so it is not the ligand. I am talking about homoleptic means ligands, same type of ligands. Here the ligand is only your oxalato compound. Okay, trioxalato. So this, which complex is compound is the most stable, so you have to find which compound is most stable. We can say the compound stability depends on the extent with which the ligand can form a ring or bondage. So see here, the most you can say En, that is that ethylene diamine. The ethylene diamine, since it is a chelating ligand, that means those ligand which can form a ring. Okay, chelating ligand En, so that En complex will be most stable. Most stable. The stability increases as the chelating of ligand increases, as the chelating properties increases. So here only number C molecule has your ethylene diamine, so the second C is your answer. Number 4, given below are the two statements. One is labeled as assertion A and the other is labeled as your reason R. Okay, that means the assertion 1 is supported by the reason. Okay, if it is supports, then only it will be true. Okay, now see, assertion A, the metal carbon bond in metal carbonyl possesses both sigma and pi character. Okay, it says that assertion in metal carbonyl bond, that is metal carbonyl bond, will contain both your sigma and pi character. The second one is saying, the reason is saying that the ligand to metal bond is pi bond and the metal to ligand bond is your sigma bond. So which one will be your correct answer? A is not the correct answer, but R is correct. Number option 1 is saying that A is not correct but R is correct. But here see, the metal carbon bond has both your sigma character and pi character, so A should be right. So it's C, A is not your answer. Number C, both A and R is correct, and R is the correct explanation of A. So we have to check whether the R is correct explanation or not. So see, R also, it is somewhat correct. There is a pi bond or sigma bond is there, so there is metal to ligand bond and ligand to metal bond is also there. But is this correct? So let us see. So see here, if there is a metal, okay, so if there is a carbon monoxide spot, so this is the pi bond and this is the bond of, you can say, or pi orbital of the metal atom, and this is your sigma bond. So from ligand to metal, it is your sigma bond, whereas from metal to ligand is it your pi bond. Remember this, ligand to metal bond is your sigma bond. That means they form strong the sigma bond, whereas the pi bond of the metal atom, so from metal to ligand, it is the pi electrons or 3d orbital electrons, so it is pi bonding. So number C. So what is the your that your both A and R is correct, but R is the correct explanation of A. R says the ligand to metal bond is your pi bond and the metal to ligand bond is a sigma bond. So this is wrong. This is not correct. Metal to ligand bond is your pi bond, whereas ligand to metal bond is your sigma bond. So both A and R are correct, and R is not the correct explanation of your A. So answer will be your C. So the next question is the IUPAC name of the complex you have to find. Okay, see here, there we go for naming. First comes your name of the cation, then comes your metal atom, and then comes your anion. Okay, so here silver, we know the valency of silver is always 1. It does not go for any other valency much, it goes for valency to be 1. So it is diaqua silver 1, dicyanido arginate 1. So your answer will be B. Okay, why it should not be dicyanido first it should be diaqua, because the positive cation comes before, or the positive or the cation, or you can say the neutral molecule will come first. Okay, now the second question, the other questions are, now we'll see the next question is the order of the energy absorbed which is responsible for the color of the complexes are, you have to will give you the highest colors. Okay, color of the complexes, which one is greater, emit more colors. The stronger the field strength, higher will be the energy absorbed by the complex. Stronger field strength, higher will be the energy, and stronger field strength will be given by the strongest ligand. So En, you can say it is the strongest. So here nickel, nickel, here it is nickel. Here nickel ethylene diamine, it is 3 molecules out here. So since it has 3 molecules of your En molecules, so here the highest is your stronger is the field strength, because higher will be the energy. So field strength is strongest here because this one comes in the it is a very strong field ligand. Then comes your, see here, this is 2 molecules of nickel, 2 molecules of aqua complex, here it is 4. So since 4 molecules of water is there, even though the ethylene diamine molecule is 2 only, but since water here it is less, so this will give more field strength than number B. So your answer will be number C. The next question is ethylene diamine tetraacetate EDTA ion is bidentate ligand, where N is 1 donor atom. It's tridentate, or it is hexadentate ligand, or unidentate. It is your hexadentate ligand. And what is the structure? So the structure is, you can write it down so that in exams, if there is any question regarding the structure, you can answer it. Okay, where there is nitrogen and your oxygen as your donor atom. See here, nitrogen is a donor and oxygen is a donor atom. CH2 C double bond O, O minus, here it is N, CH2 C double bond O, O minus. See here. Okay, so this is your EDTA. Now the next question is match the list as list 1. Here there is given some molecules are given to you, and you have to find the you can say find the magnetic moment, and you have to arrange which one has the highest magnetic moment, or which would match the following. Okay, so in Fe3 plus is your argon 18 3d5, that means 5 number of unpaired electron is there in 3d orbital. Now cyanide, since this is a strong field ligand, so what will happen? Number of electrons will pair up. So how many will be left? If it pairs out, 1 2 3 4 will pair up, only 1 will be. Your magnetic moment mu will be under root 1 into 1 plus 2. So that is your under root iron Fe H2O whole 6 3 plus. Okay, so here what happens, ligand is water molecule, so again Fe 3 plus means your 3d5, since it a weak electrons, weak field ligand. So what you can say, how many electrons will be there? There will be 5 electrons only in the outermost shell. So here the magnetic moment will be highest, that is your 5 into 5 plus 2, which is under root 5 6 7 7 5 is 35, under root 35. Okay, so next your Fe comes your Cn whole 6. Okay, for your 4 minus. So what happens, how many unpaired electron? It is Fe2 plus, so it is your 3d6. So how many unpaired electron? 0 unpaired electron. Number of unpaired electron is your 0 in this case, so magnetic moment is 0 for this. And the last one is your FeH2 whole 6. Here again 2 plus, so here iron becomes 2 plus, again here 3d6, 3d6 is there, so how many unpaired electron? 4 unpaired electron. So mu will be your under root 4 into 4 plus 2, which is equal to your 4 5 6 4 are 24. So this is under root 24. So the you always you will all have your scientific calculator calculated how many Vm will be there for all. You can say number A. Why? Because see here C is 2, because C will be 0, we have find it, and the other one, so you can know only which is the least one, that is your 1.73 is 4, so A is also 4, so answer A will be correct. Okay, so this way you can find out. So the question is the calculated spin only magnetic moment of Cr2 plus ions is you have to find. So chromium, what is chromium? What is the atomic number? It is your 24. It is 24, so it is argon 18, 4s2 3d4, so 18 19 20 plus 4, so 24. Now Cr2 plus, that means how many electron now? Cr2 plus, that means 2 electron gone. Okay, 2 electron gone from which one? This s orbital is gone, so how many left? 3d4. So how many electrons does it has unpaired electron? That is 4 unpaired electron. So magnetic moment will be your 4 into 4 plus 2, so that is your 4 into 6, 6 4 are 24, under root 24. You find the answer. Your answer will be your A. Okay, that is your 4.90 bm. Okay, so urea here reacts with water molecule to form A, which will then decompose to B. When B is passed through copper solution, aqueous solution of the copper, that time deep blue color solution is formed. So you have to find what will be the answer. So since ammonia is there, so ammonia complex will be there in the solution answer. Okay, so see here, where is ammonia? Is number C, number D, number B. There is no ammonia, so directly your answer will be number A. Okay, so if you want to know what it happened, is see, this is your urea. Okay, then if you react with water, it forms your NH4 whole twice CO3. This is your A. This, when it is heated, it gives your NH3 gas plus your carbon monoxide gas plus H2O. Now this NH3 gas, when passed through copper solution, it forms Cu ammonia complex. Okay, so this is your answer. Now, which of the following is the correct order of the increasing field strength of the ligand? According to your spectrochemical series. Okay, what we know, cyanide is the most strongest field ligand, so that will be the most strongest field ligand. So your B and D will not be your answer. Now you have to check from A and your C. Remember cyanide, because see here C2O4 2 minus, even if this is a strong field ligand, because of the small size, chlorine cyanide is the strongest field ligand. Okay, then this one. Now this is thiocyanide, thiocyanide SCN, or fluorine. Thiocyanide, because of sulfur, which is the larger in size, this is again not a good strong field ligand, so this one will be the least strong field ligand. Then comes fluorine, then will come C2O4 2 minus, and CN minus, it is the largest one, so your answer will be C. Okay, if you don't even remember the electrochemical series, you can just think this way. Here, the question is iron carbon FeCO whole 5 is your tetranuclear, mononuclear, trinuclear, or binuclear. Since nuclear word is being used, that means if there is two nuclear metal atom, that means it is your dinuclear. If it is three metal atom, so it is trinuclear. If it is four metal atom, so tetranuclear, and if it is one metal atom, so that is your mononuclear. Now see here, B is your mononuclear. Why? Because there is only one metal atom. Now then the other question is the type of isomerism shown by COCl2En whole twice. Whenever there is ethylene diamine, remember that the isomerism will be your geometrical isomerism. There is no two metal atom where there is a coordination will be there. Ionization isomerism also never possible. Linkage isomerism is also not possible, so it is your geometrical isomerism. So if you want to see the structure, see here, this is your structure of this is the octahedral structure. This is your trans. Okay, and same way, if you want to draw this one also, see here, you can draw this one. This is your cis. So your answer will be geometrical isomerism. Now, give an example of sigma bonded organometallic compound. Which one is sigma bonded? See here, is it Grignard region, pyroxene, cobaltocene, or ruthocene? See, only in Grignard region there is you can say from metal to carbon bond, it is your sigma bond. Whereas in ruthocene, so metal to carbon bond is your pi bond. So your answer is A. That is your Grignard reagent. What is the correct electronic configuration of the central metal atom? You have to find based on your CFSE. So we have done you can say in details about your CFSE in tetrahedral, octahedral splitting in other videos. You can go through it. So now see, first look at the ligand. This is cyanide. Cyanide means your strong field ligand. So a strong field ligand, what will happen? It will go for your octahedral complex, octahedral splitting, not your tetrahedral splitting. Okay, since I octahedral, so your T2G level will be first and then becomes your EG level. Now here it is +4 -1, so it is +2. Iron +2. Iron 2 plus means iron is your Fe26. Okay, that is your argon 18. 4s2 3d6. Now Fe 2 plus means your 3d6 configuration. So how many electrons remaining? 6 electron remaining. T2G contains how many shells? 1 2 3. Eg contains your 2 subshells. So 1 2 3 4 5 6. Since why? Because cyanide is a strong field ligand, pairing will take place. Your answer will be number B. Now, the geometry and the magnetic behavior of NiCO4 are square planar complexes and diamagnetic, tetrahedral geometry or diamagnetic. You have to find, or square planar or tetrahedral complex geometry. So you have to find the answer of nickel NiCO4. Again, see, this one we have done in details about this. It has just a long video on only NiCO4. You can go through that. So here what happens is that nickel, again, see, carbon monoxide is a strong field ligand. Okay, strong. Okay, what is nickel out here? Nickel here is your D8. Nickel is 28. Since carbon CO is there is oxidation state is 0, so it has how many electron? 8 electrons. That means your D subshell is fulfilled. 1 2 3 1 2 3 4 5 6 7 8. So 2 unpaired electron is there in your D subshell. Okay, but carbon is D8 and there is no oxidation state, so if it is 28, so 4s2 will be there. Okay, so 3d8 4s2, this is your final electronic configuration. Now what happens is that since carbon CO group, it is, you can say, strong field ligand, so it will pair up. It will these electron of s orbital will come and pair up in 3d orbitals. So if it pairs up, it will form your now 3d10 configuration. It will form in your NiCO4 state. Okay, so it will be 1 2 3 4 5 6 7 8 9 10. Left now empty s and your p orbital. So CO 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 CO. So it forms your sp3. So if it is sp3, it is your tetrahedral. Since it has taken your outer orbital, so it is your tetrahedral, and since it is paired, so it is diamagnetic. Okay, so it is your tetrahedral geometry and your diamagnetic. Number B is your answer. So the question is the correct order of the stoichiometry of AgCl when formed silver nitrate when it is excess treated with this complex CO, Cl2, 6NH3, 5NH3 and COCl3, 4NH3. So since here, see here, it is 6, it has become 5 and there is difference of 1 mole is there. So here it is 3, here it is 1 and it is forming 2, it is not possible. 3, 2, 1, it is possible. 2, 3, 1 is also not possible. This is also not possible. So your answer will be number 2. Why? Because see here, it is 6 moles of 6 ammonia. It is replaced by your silver nitrate. Okay, so it forms AgCl. AgCl, if it is forming, that means it is taking your what it is taking. It is taking 1 silver molecule. Again, then it is taking your 1 chlorine. Okay, so it will be 3 moles, then 2 moles, then 1 mole. Now correct increasing order for the wavelength of the absorption of the visible region of these complexes CO3 plus S. So the more is the field strength, more is the absorption. That means En, this is the highest, then ammonia, then water. What is the strong weak field ligand? So less splitting is found. So number D is the answer. Thank you. We have completed mostly whatever question has come and will be coming. So I think this will be the best video for you for a practice, and stay tuned. We'll be coming with electrochemistry next.